Calculation 4 in Chapter 1 Redlich-Kwong equation of state. Estimate the molar volume of isopropyl alcohol vapor at 10 atmosphere and 473 Kelvin using the Redlich-Kwong equation of state. The Redlich-Kwong equation of state is given by this equation, where P is pressure, T is absolute temperature, and V is molar volume. Also, R is gas constant. There are two parameters of a small a and a small b in terms of critical temperature Tc and critical pressure Pc. Let's assume a critical temperature of 508.2 Kelvin and a critical pressure of 50 atmosphere for isopropyl alcohol. Also, let's use a gas constant of 82.05 in appropriate units for this equation. Let's calculate values for small a and small b. A is equal to 0.4278 8205 square atmosphere square centimeter to the power 6 gram mole square K square times Tc to the power 2.5 508.2 Kelvin to the power 2.5 divided by Pc of 50 atmosphere. As we see, A would be calculated as 3354 times 10 to the power 7 atmosphere centimeter 6 Kelvin 0.5 divided by gram mole square. This is after simplifying for the units. We can calculate B as well in the same way. B is equal to 0.0867 times 8205 times 508.2, which is the critical temperature, divided by 50 atmosphere, which is pressure, and if we put the appropriate units, we will come up with B equal to 72.30 centimeter cube per gram mole. With these values of small a and small b, and also having the value of pressure of 10 atmosphere and temperature of 473 degrees Kelvin, we have all the values in this equation except V, so we are going to solve for V. So let's insert the numbers. 10 atmosphere equals to 82.05 atmosphere centimeter cube per gram mole K multiplied by temperature of 473 Kelvin divided by V, which we don't know, minus B, which is 72.30. And the V and B have the same units of centimeter cube per gram mole. Minus the second term, A 33.54 times 10 to the power 7 atmosphere centimeter 6 Kelvin 0.5 divided by gram mole square, and in the denominator of the second part we have temperature to power 0.5 400 73 degrees Kelvin to the 0.5 divided by the product V times V minus B. And this product has the units of a square of volume, which would be centimeter 6 per gram mole 2. If we solve for V, we will get V equals to 4,311 centimeter cube per gram mole. This is the molar volume of isopropyl alcohol vapor. An alternative form of Redlich-Kwong equation is shown here, where Z is compressibility factor, H and A over B are parameters of the equation. Note that all these three terms, it means Z, H and A over B, are dimensionless. We can calculate values for H. H would be equal to B, which we calculated earlier as 72.30 over V, and you recall that 72.3 had the units of centimeter cube per gram mole. That is the same units as V. Also, value for A over B equals to small a 33.54 times 10 to the power 7 atmosphere, centimeter 6 Kelvin 0.5 divided by gram mole square. This was A divided by B or T to the power 1.5. B 72.3 centimeter cube per gram mole. R is 82.05 atmosphere centimeter cube per gram mole degrees Kelvin, and divided by temperature of 473 Kelvin to the power 1.5. We can solve for A over B. A over B would be dimensionless and equal to 5.5. We can insert these values along with the values of pressure R and T in the equation, and the only unknown would be V that we can solve for. So pressure 10 V divided by RT, which is 82.05 times temperature of 473 equals to 1 minus H, which is 72.3 divided by V, minus A over B, which is 5.5 times H, which is 72.3 divided by B, divided by 1 plus H, 1 plus 72.3 divided by V. And in this equation we can solve for V, and we will get 4,300 centimeter cube per gram mole for the value of molar volume using alternative form of Redlich-Kwong equation.